In my today's class, I'm going to discuss about another aspect of hypothesis testing. And I will tell you how to find this level of significance and the probability of committing type 2 error along with the power of the test in great detail by explaining a few problems to you. So first of all, my today's class is actually a problem-based class where I'm going to solve a few problems on these topics. So my today's topic is how to calculate alpha, beta, and 1 minus beta, where alpha is the level of significance. Sometimes, as you know, the level of significance is also called size of the test or size of the critical region. It is also known as size of the test or size of the critical region. And beta is the probability of committing type 2 error. Whereas alpha is the probability of committing type 1 error. I must write this line also over here. Probability of type 1 error. And 1 minus beta is actually called the power of the test. Okay. And the prerequisite in this regard is the meaning of these words that I must remind you. Type 1 error means reject your null hypothesis given that your null hypothesis is true. That is called type 1 error. Type 2 error means accept your null hypothesis when your null hypothesis is false. And 1 minus beta, that is the power of the test, is actually a probability of accepting a null hypothesis when null hypothesis, sorry, not accepting, rejecting the null hypothesis when it is actually false. That is called 1 minus beta, or it is also known as the power of the test. So these are the definitions that I discussed in one of my earlier classes. I'm going to explain the things and I'm going to tell you how to calculate these probabilities with the help of a few problems. My first problem goes like this. First of all, I'm going to write the question over here. If x greater than or equal to 1 is the critical region for testing h naught which states that theta is 2 against h1 which states that theta is 1 on the basis of the single from the population fx comma theta is theta into exponential of theta minus theta x, where x lies between 0 and infinity, obtain alpha and beta. This is the question. Now, first of all, remember that to solve this type of problems, we have to keep in touch with the definitions that I have mentioned above. If you forget the definitions, you will not be able to solve these particular problems. Now let us come to the problem. It is written that x greater than or equal to 1 is the critical region. You know that the critical region is the rejection region. So if I want to draw the graph, the so-called normal curve, then if I consider this point x equal to 1, then the region on the right hand side of this point is your critical region. Critical region is also sometimes called the rejection region. Two hypotheses. One is the null hypothesis is given against its corresponding alternative hypothesis, and this theta is some population parameter. We do not know what is the meaning of theta here. At least we can say that it is one of the population parameters. It could be mean, it could be variance, anything, but anything which is related to population. And the entire statement is based on the basis of a single observation from the population. Okay. Now, after this line, they have put a comma and they have mentioned this particular function fx comma theta, theta into exponential of minus theta x. What is the function is representing, and why after writing this word population, they immediately wrote this function where the independent variable is having this range. The meaning of this sentence is that the population from which the observation will be taken, this population is having a probability distribution of this form. And what is the probability distribution? Can we identify this probability distribution? Yes, of course, we can identify the probability distribution. It is the well-known exponential distribution. Now, the problem is saying that if the scenario is that we are dealing with a population from which a sample is being drawn, and the population is following exponential distribution, and about that particular population we have constructed this null hypothesis and this alternative hypothesis. What is the probability of committing type 1 error? What is the probability of committing type 2 error? Okay, so you remember this alpha and this beta, these are actually the probabilities. So I'm going to calculate this for you. So pay attention. I'm asking all of you to pay attention, and these problems are actually very important from examination point of view. We know that alpha is the probability of committing type 1 error. I have already mentioned it over here. What does this mean? So actually we are supposed to find the probability that we are going to reject null hypothesis when your null hypothesis is actually true. Okay. Now, when do we reject the null hypothesis? When the values fall in the critical region, then we reject the null hypothesis. And what is the critical region here? Here the critical region is this one. This region depicted by x greater than or equal to 1 is the critical region. So actually we are interested in finding the probability that x is greater than or equal to 1, given that your h naught is true. given that your H naught is true. I am writing in short. What is the statement of H naught? H naught statement is theta is equal to 2. So we can write it as probability of x greater than or equal to 1, given that theta is equal to 2. Do not think that this slash is generally we have known that whenever we write A given B, this means something about the conditional probability, but here the thing is not like this. Actually, this slash is being the slash we used to write in the case of writing sets. That is the set. That is the slash is denoting over here. It is the meaning of given that under the condition that theta equals to 2, we are considering the critical region. We are going to find the probability. And since this population is actually following a continuous probability distribution, so to find the probability that x exceeds 1, we are actually supposed to find the integration of this probability function. So it will be from 1 to infinity, integration of this function, which is theta into e to the power minus theta x. Theta is the population parameter, dx. But under the condition that null hypothesis is true, that means we are going to substitute theta equal to 2 over here in this in the function itself. So your expression is becoming integration 1 to infinity 2 into e to the power minus twice x dx. Why am I substituting 2 over here? Because we have assumed that the null hypothesis is true. So now the rest of the part is on about calculating the probability, and I know that you can do it very well. So it would be this, and then you just do not wait for me. Try to find it by yourself quickly. You don't have to write anything on the chat box. Now, if I substitute these points over here, so we get this and this. This part, the first part will become 0, and the second part will become 2 into e to the power minus 2 by 2. So this is just e to the power minus 2, which is 1 by square. So this is the probability of committing the type 1 error. Just look at what have I done. I'm again explaining. Alpha is the probability of committing type 1 error. It is also known as size of the test. It is also known as size of the critical region. Type 1 error means rejection of null hypothesis when null hypothesis is true. Now, we reject the null hypothesis when data fall in the critical region. Critical region is defined here as the region depicted by x greater than or equal to 1. So this becomes to find the probability that x greater than or equal to 1, given that null hypothesis is true. But what is the null hypothesis? It is theta equal to 2. Now the probability is calculated by considering the probability function that the population is following, and to integrate it from the range 1 to infinity. But here the population parameter theta has been assumed to have the value 2. So we are substituting 2 over here, and the rest is just to calculate the integration and to put the definite values, upper limit and lower limit. And this is the probability with which you can commit type 1 error. So this is part 1 of the problem. That means I have found the alpha part. Let us now find the beta part. Beta is probability of committing type 2 error. Now, what is type 2 error? In type 2 error, we actually accept our null hypothesis when your null hypothesis is false. Now, when do we accept the null hypothesis? When we accept the null hypothesis when data is not in critical region, or in other words, you can say the data is in acceptance region. Okay, now if x greater than or equal to 1 is the rejection region, so it is quite obvious that x less than 1 will be the acceptance region. Okay, so this probability is actually to find the probability that x is not greater than or equal to 1 when h naught is actually false. Or in other words, we can write it as probability that x is lying between 0 and 1, or if I write it in a more general way, x is less than 1 when h naught is false. If h naught is false, that means h1 is true. Okay, now if I want to find the probability that x is less than 1, we have to consider this probability function. But you be careful about the probability function. This probability function is defined for certain range of the independent variable x. Actually, x greater than or equal to 1, if this is the region W, then its complementary region will be x less than 1. And x less than 1 means x is taking the value from -infinity to 1. In between x, the x is falling. But according to our problem, the probability function has a lower limit, which is 0. It cannot go beyond 0. I mean, it cannot be less than 0. This is the bound, which is actually defined for the kind of probability function that the population distribution is following. So this part actually will reduce to probability that 0 less than or equal to x less than 1 when h1 is true. So in short, I am writing this. This implies this is equal to, now we are going to calculate the probability from 0 to 1. The function is theta into e to the power minus theta x dx. But you are considering that h1 is true. What is the value of h1? The h1 is this one. h1 is theta equal to 1. So under the condition that theta equal to 1, you are going to calculate the probability, which is nothing but equal to the integration from 0 to 1. Put theta equals to 1 over here. So 1 into e to the power minus 1x, that means e to the power minus x dx. So this is the probability that you are going to calculate. And the rest is very simple. So if I put the lower and upper limit and lower limit, so we are going to get so this is the probability with which you can commit the type 2 error for the given problem. And in this particular problem, although it hasn't been mentioned, they have mentioned that you are supposed to you are supposed to calculate the probability alpha and beta only. Now, if I put one extra part that also find a power of the test, what will you do? Power of the test means the kind of power you have when you are rejecting null hypothesis, treating that it is indeed false. That is called the power of the test. So to calculate the power of the test, part C, you need to calculate this quantity 1 minus beta. So this will be 1 minus e to the power minus 1, which is e to the power minus 1, which is 1 by e. That is the power of the test. Or if you want to calculate the power of the test directly, that means if someone thinks that no, I'm not going to calculate in the current way. So in that case, what you are supposed to find, reject H naught when H naught is false. Then you have to start from scratch, and then you are supposed to calculate the probability. So that is how, this is my page 1. That is how we calculate the level of significance and the power of the test, and the probability of committing type 2 error also. Let's go to the next problem. Problem number 2. This type of problem in the examination is a shear shot. Let P be the probability. Let P be the probability that a coin will fall head. The coin will fall head in a single toss in order to test H naught. One means the null hypothesis. The null hypothesis is small p equal to half against the alternative hypothesis that small p is equal to 3 by 4. The coin is tossed 5 times. The coin is tossed 5 times, and H naught is rejected if more than 3 heads are obtained. Okay, find the probability of committing type 1 error, type 2 error, and the power of the test. This is the question. Now this question is actually a kind of different one. In this particular problem, if I want to compare the previous problem with the current one, the first difference that I can see is directly they haven't mentioned the probability function that the population of coin tossing is following. But from our previous experiences, we can easily say that this particular situation that is in front of us actually is following binomial distribution. How can I be so sure about it? Okay. In binomial distribution, we need 2 parameters. One parameter is small n and another parameter is small p. Now you read the question, you will find that the parameter small n is mentioned over here. It is given, and about the parameter small p, something has been assumed in both null hypothesis and in alternative hypothesis. So obviously we can treat the problem on the basis of the binomial variable. So first of all, before we start solving the problem to find alpha beta, we must define a random variable in the following manner. Let x be the random variable, let x be the random variable which counts the number of heads. Okay, now the population of toss is following binomial probability law. Binomial probability law. Okay, that much we have come to know from the given problem. Now, one thing that may be hovering in your mind is that probably you are thinking that in the null hypothesis, P equals to half. So why they have mentioned in the alternative hypothesis P equals to 3/4? Probably you are thinking that in alternative hypothesis they also have to write P equals to half. Okay, because probably you are thinking that this alternative statement is the complementary of the null statement. It is not like that. Do not think like that. Remember that in your null hypothesis, if you write P equals to half, that means in alternative hypothesis, you are actually writing P not equals to half. Okay, P not equals to half means P can be anything. So they somehow from their experience have come to know that it may also happen that for a single the particular coin with which they are experimenting is not unbiased one. So if the coin is not unbiased, it is biased, it can have any probability. So they have specifically mentioned that P equals to 3/4. Okay. Now, therefore, these two are not actually directly connected. So do not think that we are to write P equals to half over here, because this is the complementary probability of that. This is not the complementary probability of this. This is not the complementary probability of this. This is a separate statement and this is a separate statement. If you want to know the complementary probability corresponding to this statement, it is half. Indeed, it is half. If you want to find out the complementary probability with respect to this statement, it is 1/4. So you keep this in mind. Okay, I know where you can what type of problem you may face, what you are thinking. I can very well understand. Now we know that the null hypothesis will be rejected according to the problem if more than 3 heads are registered. More than 3 heads are registered, which implies that it is this particular part is given. This is given. This implies that the critical region, if I denote this critical region by a set called W, then this is actually the region where X is greater than 3. Okay. We are supposed to find the type 1 error now. Now we are in a position to calculate the type 1 error, probability of type 1 error. So probability alpha is calculated in the following manner. Probability of type 1 error, which means probability of calculating the calculating the probability of rejecting a null hypothesis when null hypothesis is indeed true. Now we reject the null hypothesis if the random variable value falls in the critical region. So we must have this. Given that null hypothesis is true, given that the parameter P is equal to half. So first of all, our job is to find the probability that X is greater than 3, where P is equal to half, N is equal to 5, and X following binomial distribution with NP. That probability that I'm going to find right now. And we know that probability that capital X equal to small x is given by this probability law, where X is from 0, 1 to up to N. Now, if you want to find probability of X greater than 3, there are how many possibilities are there? There are 2 possibilities, because in this particular scenario, the possible values of X are 0, 1, 2, 3, 4, 5. We want the probability of X greater than 3, which is probability of X equal to 4 plus probability of X equals to 5, which is equal to 5C4, and your null hypothesis is true. That means you are assuming half over here, half to the power 4. Small q is also half, because it is the complementary to that. I must write here small p plus small q equals to 1. So that is half to the power 5 minus 4. To the power 5 minus 4. 5C4 is similar to NC1 is similar to NCN minus 1. So 5C4 is similar to 5C1, and 5C1 is 5, and this will become half to the power 5 plus 5C5 half to the power 5 half to the power 5 minus 5, which is equal to plus 5C5 means 5C0, that means 1, half to the power 5 into half to the power 5 minus 5 means half to the power 5. Now you can take half to the power 5 common, and this will become 5 plus 1, that is 6. And just you are supposed to calculate this probability with the help of your calculator. Let me calculate this probability. So this is coming out as, according to my calculation, it is coming 0.1875. So we have found, what is this probability of X greater than 3? That is our size of the test, that is alpha. So we have calculated the probability of type 1 error. I am activating the chat box so that you can put your roll numbers here. 4 minutes 5 seconds is left. Quickly you put your roll numbers in the chat box so that I can save the chat. This is page number 3. Students, are you listening? Write your roll numbers in the chat box. It is open now. Okay, so let us go to the next page. Next, I'm going to calculate the probability of committing type 2 error. So beta is probability of committing type 2 error, which means probability that we accept H naught when H naught is false, or probability that we accept H naught when H1 is true. We will accept H naught when X is less than or equal to 3 because X greater than 3 is the region of rejection, which implies probability of X less than or equal to 3. But right now at this moment H1 is true. That means P equal to 3/4. That is true. So we are going to put P equal to 3/4 over here. And you can do this particular problem in two different ways. Here also the thing is capital X is following binomial distribution with n equals to 5 and parameter P equal to 3/4. I can see 47 participants, only 37 participants have so far written in the chat box. Other 48 participants have not written their roll numbers in the chat box. Okay. So now you are going to calculate this probability. This probability can be calculated in two ways. Either to calculate probability of X less than or equal to 3, you do it in the following manner. You find this. Or you can calculate this probability by simply subtracting the opposite from 1. And this is probability of X equal to 4 plus probability of X equal to 5. But remember, here n equal to 5 and P is equal to 3/4. That will give your beta. And from there you can calculate 1 minus beta. So I'm leaving this particular problem to you to finish. That is your homework. So let's meet in the next session to do more problems on this.